As byproduct, internal combustion engines produce a variety of toxins, amongst them a prominent pollutant, a reddish-brown gas, nitrogen dioxide. NO2, when synthesized with water vapor, forms nitric acid, causing acid precipitation. About 50% of NO2 comes from means of transportation, such as cars and buses, and contribute to heart and lung problems, causing asthma and bronchitis. When clouds are present, nitrogen dioxide dissolves in water and then, like carbon dioxide, hydrolyzes in a series of equilibrium reactions. Nitrogen dioxide reacts with OH to form nitric acid. The gases can be carried hundreds of kilometers in the atmosphere before they are converted to acids and deposited. As lakes and rivers become more acidic, biodiversity is diminished. At pHs lower than 5, most fish eggs will not hatch, and lower pHs can kill adult fish. EPA states, of the lakes and streams surveyed, acid rain caused acidity in 75% of the acidic lakes and about 50% of the acidic streams.
Hello, Victor here. Today we're going to talk about a brief overview of acid rain. Well, I believe it is an engineer's job to play a major role in protecting the environment. Moving on, we look at the causes of acid rain, which is primarily due to chemical gases such as SO2, which is sulfur dioxide, and NO2, nitrogen dioxide, which are released in the air by cars, exhaust pipes, and factories. The sulfur dioxide and the nitrogen dioxide then dissolve in rainwater to form acid rain. Now we shall look at the equations that form acid rain. Well, first off, SO2, sulfur dioxide, combines with oxygen to form SO3, sulfur trioxide, which readily dissolves in water to form sulfuric acid. The next equation regarding acid rain is H2O, water, plus N2, nitrogen, plus NO2, nitrogen dioxide. They combine to form two acids, HNO2, nitrous acid, and HNO3, nitric acid. Next off, we shall look at the effects of acid rain. First of all, it will decrease the pH of pond water, which increases the acidity of pond water, so marine life can't survive. It also corrodes buildings, and it also affects the health of people with respiratory diseases such as chronic bronchitis and asthma. Next, we look at ways to prevent acid rain. First off, we can use less fossil fuels and use more alternative energy sources such as solar energy and biomass. Then, we can install cars with catalytic converters which convert harmful gases such as carbon monoxide and nitrogen monoxide into carbon dioxide and nitrogen.
Okay, we are learning about the environmental effects of acid rain. Acid rain is basically the compounds that form acid or mixing with the water in the clouds and coming down as acidic rain. Acid can be created at home using various day-to-day ingredients. One of them is vinegar, or you could use also lemon juice that has a lot of acid. So what we are going to do in this demonstration today is to see the effect of acid rain on sprouting of mung beans. These are a special kind of beans, and you could use actually most of the types of beans which have hard shell on the outer side. So we are using here 3 different bowls here. Each of these bowls is filled with 20 beans, 20 seeds of these mung beans. And we are going to pour plain water in this one, and slightly acidic water in this bowl, and highly acidic water in this bowl, and see every day, tomorrow, day after, and a day after that, how this acid changes the sprouting of these beans. So let's actually prepare this and add plain water to the first one. This is plain water, just the water from the faucet. I'm going to add enough water so that these beans are all immersed in the water. Okay? Now, the slightly acidic water I am preparing by adding vinegar that I have here. You know, this is a bottle of vinegar, and I'm going to add 2 spoons of vinegar to this. So this water in this cup is slightly acidic. I'm going to mix this and use this water. This is slightly acidic water, and I'm going to pour slightly acidic water in here. There are 20 beans in this cup, in this bowl also. And I'm going to prepare highly acidic water here with the same vinegar. I'm going to add 5 spoons. 1, 2, 3, 4, 5. This is a little bit stronger than the other acid that we prepared. Now I'm going to add this highly acidic water to this bowl to the same level. And as the water evaporates, whatever type of water, as the water evaporates, we need to refill with the same kind of water. Plain water in this bowl, slightly acidic water in this bowl, and highly acidic water in this bowl, and observe the results. And what I want you to now hypothesize is which one would have the significant effects. Which one would have the significant effect, or which one of these bowls will have more sprouting than the other. And when you look at day 1, day 2, day 3, I need you to count the number of seeds that are sprouting, and you can prepare a plot. Let's say on day 1, the plain water ones sprouted 6 out of 20, which means 30% have sprouted. Slightly acidic ones, 4 out of 20, so that's 25%. Highly acidic one, 6 out of 20, that's again 30%. So you can plot that as a function of time and see at the end of 4 or 5 days how many of these seeds sprout. Let's watch for 3 days. Okay, we are on day 3 today, and you can see on day 1 itself we had about all 20 out of 20 sprouted in this plain water, and slightly acidic water we didn't have any sprouts. Even today we don't have any sign of sprouting in highly acidic water. That is the impact that you can see of the acidity on sprouting of seeds. Now you can imagine what it would be like for the entire planet if it is covered with acidic rain, and what would be the impact on agriculture, what would be the impact on food supply chain to the humanity. So that is what we learned from this exercise.